Hello friends, welcome to Source Code Management training session. Source code management is an enterprise critical resource that should be implemented on secure servers with effective backup procedures and well-defined disaster recovery procedures. Sadly, some organizations fail to realize the importance of robust source code management system until it is too late. Too often, we find teams not utilizing source code management features effectively, missing out on key benefits and sometimes even losing essential source code. Hence, understanding source code management and implementation in projects is very important. Today, I am going to explain about a code hosting platform that is GitHub. Before proceeding, I would like to introduce myself. My name is Ganesh Hegde, working as Senior Engineer at Kpro Solution Private Limited. Kpro is a leading provider in data lake, cloud implementation, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile application development. Let us see the overall course content of this series. In the module 1 and module 2, I will be explaining about SCM and GitHub. In module 3, I will be explaining about Git and some basic commands of Git. And finally, in the module 5, I will explain how GitHub is accessed through Git CLI. Let us focus on today's agenda. First, I will be explaining SCM and its purpose, then SCM tools in the market, GitHub and flow of activities in GitHub, and then I will show repository creation, branch creation, committing code, creating pull request, merging pull request in GitHub web interface. Let us see SCM. Source Code Management System, or SCM, is a centralized system which manages multiple versions of same files, so that when the file is modified, the old version is still be available for any use. Let us see its purpose. Source Code Management System is a centralized system. Project team members can connect to this system from any part of the world. Generally, it contains a module wherein users and their roles are defined. With its various features like branching, code committing, pull requests, etc., it eases development process. It supports versioning. Let me explain this in detail. Whenever there is change in the existing code or new file is added to the code base, system will assign a new version. In case the new code is not working, then developers can go ahead and restore with the previous stable code. Source Code Management System also supports scalability for the growing code. Many of the source code management systems are cloud-based, and they are distributed as well. Hence, it pays enough priority to disaster recovery aspects. Let us see some of the SCM tools available in the market. These SCM tools can be classified into three categories: client-server model, distributed model, and local data model. Let me explain you what exactly client-server, distributed model, and local models are. As name indicates, client-server model contains a server which will be listening for client's request to serve. In this case, server will hold all the codes along with this metadata like versions, etc. Example for client-server model are VSTS, Team Foundation Server or TFS, and Rational Clear Case, Visual Source Face, Source Safe. These are from proprietary area. From open source section, Subversion is prominent. CVS is there since long time. OpenCVS, CVS NT are some of the examples. In distributed model, the code is not necessarily kept in the centralized location. All its metadata and source code can be created in each system, and it can be pushed to the centralized location also. Proprietary distributed model examples are Visual Studio Team Service, Bitbucket, GitHub, and Sun Workshop Teamware. You may ask one question: why this Visual Studio Team Services is listed in distributed model as well as client server model? Because VSTS or Visual Studio Team Services supports TFS as well as Git. That's why it is listed in both sections. Git is a very popular tool, and Mercurial, Bitkeeper, and Fossil are other examples. In local data model, the code is and the team member should access that system to modify the code, and they have to keep the code in that system. Let us see GitHub, which is a which comes under distributed model. GitHub is a code hosting platform for version control and collaboration. It lets you and others work together on projects from anywhere. This is a web interface, and you should have a valid credential to access these systems. Let us understand how the activities flow in GitHub code hosting platform. The flow is branch based flow. There will be a main branch, and at any point of time it should contain stable code. The activity involves in 6 phases: creating a branch, committing modified code, pull request, which is a kind of raising a review request, reviewing the code, and merging the code to the main branch. Don't worry if you don't understand these terminologies. I will be explaining this in detail in further slides. Let us understand what is repository in GitHub. A repository is usually used to organize and maintain a single project. Repositories can contain folders, files, images, videos, spreadsheets, and datasets, anything the project requires. I'll show you how a repository can be created in a web interface of GitHub. The web interface URL is https://github.com. In order to access this, you should have a valid credential. To get that, you need to sign up. It requires email ID, username, and password. Once you submit this information, the site will send you an email. You have to activate your account, then you will be able to sign in. I have done all these activities, so I'm going to sign in directly. After successful sign-in, you will be taken to this page. It contains many reading materials, and you can explore GitHub by clicking on this. A new repository can be created by clicking on this button, or start a new project, or you can select new repository from this drop down. Some detail need to be provided to create a repository. So I am going to give repository name like training, optional description. I am creating this for training. Then 2 options: public or private. If it is public, then the content of this repository is visible to all. On the other hand, if it is private, you can control the visibility of the content. For instance, I am selecting public. Then you can generate a readme file when the repository is created. I am selecting this option and I am clicking on create repository. Now the repository is created. This is the repository name, and the description which we entered is coming here, and the readme file in the repository, that is the single file, and its contents are like this. There are various tabs like issues. When any issue need to be created, here it can be created and assigned to team members. This is pull request tab. Don't worry about the pull request, I will explain you. Projects, whatever the projects you have created, that will be listed here. Wiki you can create with the information about the project. Insights give various statistics related to this repository. In the settings you can change various options. Let us look at training. In the repository you will see various things like 1 commit, 1 branch, 0 releases, contributor, etc. Don't worry about these things, I will explain you in later slides. This is the drop down of branches. By default there will be a master branch and it is selected. That's all about repositories. Let us go back to the slides. Branch. By default, every repository contains one single branch, that is master branch. If any new changes need to be done to the existing code, a new branch is need to be created, that is a recommendation. Consider feature branch is created from master branch. Now the feature branch will contain all the content of master branch. When team member works on the code, they will be committing the code back to the feature branch. Committing means saving the code. So once the code is stable, then a pull request is created to review the code. Once all the reviews are implemented, the feature branch will be merged to main branch, and then the code is deployed in the target environment. Let us see in the web interface how to create a branch. Click on this drop down and start typing this. So it asks create branch feature from master. Select that one and the feature branch is selected. Now if you see the drop down, you will see two branches, master and feature is selected. So these are the content of feature branch. Let me modify this readme file to demonstrate the master branch is intact. I just added test here and give optional message, and there are two options: commit directly to the feature branch or create a new branch. Since I have already created feature branch, I'll select first one and click on commit changes. So you can see here test is coming. Let us go back and check master branch file to make sure it is intact. So there is no test, so the changes made is there in the feature branch. Alternatively, if you have a source code in your hard disk, you can upload them by clicking on upload files. You have to drag and drop the files to here, this region, and it will be added, and then you have to save with proper messages. So this is how a branch is created in GitHub. Let us see different activities performed in GitHub. Code commit. So we have already did couple of commits in our activities in web interface. It is nothing but saving the modification to the repository. Pull request is a way of proposing your changes and requests, requesting that someone to review and pull in your contribution and merge them into their branch. So when you create a pull request, you will be specifying who will be reviewing that, and whatever the reviewer provides a message, everything will be documented. Merging pull request is bringing all the new code to the main branch. Let us see how this can be done in web interface. This is our repository, and this is the feature branch, and we have done some changes here. I'm going to create a pull request by clicking on new pull request. So I'm going to give a title to it, review modified, optional message like please review, then I'm going to assign to myself because nobody is there in this project. Then I am clicking on create pull request to create it. Now a pull request is created, and you can see this is the message which I had given, and these are the commits which I have made to the branch. If I click here, it will show me what are the changes done to that file. See, this is the readme file old, and this is the new readme file, and test is added here. That's what it is showing here. This can be reviewed, and a proper comment can be provided here. So since this is in my name, it is not allowing me to approve. I can just give comments here. I give it like looks good for me. Then I will submit this, and the message is coming here. Okay, let me merge this pull request by clicking on this merge pull request. Now it again ask for confirmation. I am confirming this, and it shows pull request successfully merged and closed. Now it asks whether it need to be deleted or not. I am clicking on delete branch. So if you are done delete by mistake, you can restore also. Now let us go to the training main page and see what are the branches available here. Only one branch, and the test which is done in feature branch is coming to the master branch. So we have created a branch, modified the content of the new branch, and merged that to main branch. Yeah, that's all for today. Let me quickly summarize what are the things we have seen today. We have seen SEM and its purpose and some tools available in the market. Then we have seen GitHub and its flow. We have seen how to create a repository, how to create branch, how to commit code, pull request, and finally we merged the pull request to the main branch. Thank you for watching this video. In the next video I will be explaining about Git, DVCS, Git versus GitHub, Git installation, getting started with Git, and some basic commands. It will be more exciting. Kindly provide your valuable feedback as a comment and let us know any topic you want us to make video of, or any issues which you are facing in your project. Please email to us at feedback@kpro.co.in. Thank you very much. Let's keep learning.